The negative valence assay's purpose is to provide additional evidence that C. elegans model a behavior akin to fear when being zapped with alternating current. This is a chemotaxis assay that is performed to model associative learning behavior. Through this assay, the worms will hopefully exhibit an aversive response to an attractive odor after being zapped while exposed to said odor.
From the Bargman 1993 paper, the odors that C. elegans preferred the most was found. Therefore, we chose isoamyl alcohol to conduct this assay. Before the assay begins, we mark the assay plates with circles on either side of the plate with a 2 cm diameter. The sodium azide and different odors will be placed into these circles respectively. Additionally, the 1:10 dilution of isoamyl alcohol in ethanol is created every time before the start of the assay.
This assay is split into 4 parts. The first part is the experimental assay. The training plate is spotted with 2 dots of isoamyl alcohol, each 1 centimeter away from the midpoint of the plate. This is spotted 10 minutes before the worms are zapped. In the meantime, the worms will be washed. This is done by collecting young adult worms from a plate with 1,000 microliters of NGM buffer.
They are then placed in a worm trap. A worm trap is created through cutting a 1,000 microliter pipette tip and attaching it to a square cutout of mesh by melting the pipette tip. The worms are washed with NGM buffer through the worm traps 3 times. The 2 circles on either side of the chemotaxis plate are then spotted with 0.5 microliters of sodium azide paralyzing solution. This will paralyze the worms if they were to enter the circles of either the isoamyl alcohol or ethanol based on which circle they enter and allow them to be counted.
After washing the worms remain in the worm trap and are placed on the training plate that was spotted with isoamyl alcohol previously. Copper plates are placed in the training plate to allow the current to run through the plate. They are zapped for 60 seconds of 30 volts, 4 Hz, and 80 milliamperes. The chemotaxis plate is spotted with the diluted isoamyl alcohol and the ethanol in their respective circles. Subsequently, the worms are removed from the worm trap with 30 microliters of NGM buffer and then are placed onto the chemotaxis plate.
After 2 hours pass by, the number of worms in the isoamyl alcohol circle, the ethanol circle, the worms outside of these circles, and the worms in the starting point are counted. The chemotaxis index is then calculated accordingly.
Next, the 2 control assays will be performed. In one control, the worms are exposed to the odor in the training stage but will not be zapped. The purpose of this control is to confirm that the worms will still find the odor attractive, even when they go through obstacles and adaptations such as the worm trap and through the training period.
In the second control, the worms will be zapped for a minute in the training stage without being exposed to the odor. The purpose of this control is to confirm that the worms won't experience any physiological damages from the zap, and to confirm that their response to the odor is not due to any deteriorating senses.